Hello everyone, I'm back with another video. This is a guide to do a mix between within group ANOVA test. Here in this example, we want to see the changes of concentration level in 20 members of 4 different offices corresponding with 3 tests. Before conducting each of these 3 tests, we give the members 3 different treats and we want to see which test and which office has been more significant. Here, between subject factor is office with 4 levels, office A, office B, office C, and office D. And within subject factor is test with 3 levels. So the aim of the study is to see different offices, whether resulting in different concentration level, or it is the tests that differs this concentration level, or there is an interaction between offices and tests. So, as I said, the first variable is office, refers to between subject factors with 4 levels, A, B, C, D, and different tests refer to within subject factors. For example, person number 1's concentration level from office 1 has been measured by these 3 tests. The assumptions of mixed group ANOVA are similar to those in repeated measure one-way ANOVA, so you can check those assumptions. And let's begin. So go to Analyze, General Linear Model, and Repeated Measures. And here, write test within subject factor name. And then enter the name of levels, which is 3. And click on Add, and then Define. This will open up a new box called Repeated Measures. Here we define levels of within subject factor and between subject factor. So move each of these within subject variables to this box. And these are those that we measured on repeated occasions. So, and now move your between subject factor to the between subject box. And now click plots. Here, since we are interested in interaction between within subjects and between subjects, so we need to request a plot of interactions. So, and move tests to horizontal box and offices into separate lines box, and then click Add and Continue. So now click Post Hoc. So move offices to Post Hocs 4, and then click 2 key to run 2 key post hoc comparison for offices, and then continue. And now click on EM means and select test interaction offices and tests and move them to the display means for. So, and then click compare main effects and then select the Bonferroni method. And so now from options, select descriptives, estimates for effect size, observed power, and homogeneity test. So now click OK. So here is the results. And this table gives us mean and standard deviation for each of these 3 tests. So as you can see, And we check this table to evaluate the assumptions of the test. And as you can see, p-value is greater than 0.05. So the assumptions are met. And based on Levine's test, the F value indicates that none of them is significant. So the assumption is met for each test. And scroll down to the table of tests of within subjects effects. So here we just need to check severity assumption. And as you can see, the p-value for severity assumed is 0.027, which is less than 0.05. And it says that changes in concentration of employees using these tests are not equivalent across 4 offices. Now scroll down to table tests of between subjects effects. So we follow the line for offices, and as you can see, the p-value is 0.444, which is greater than 0.05. So there is no significant difference between concentration of members measured based on which office they belong to. So go to table estimated marginal means, and then go to table 2, which is for tests, and it gives us mean concentration levels for the whole sample and resulting from each test. It says that members have best levels of concentration after test number 3. However, the question is which one of these tests is significantly different from the rest? To answer this question, we need to check the table of pairwise comparisons. So it shows that the levels of concentration increased throughout the tests, but we'll come back to that later after checking the interaction effects. But before that, go to the multiple comparisons table. And this is for differences between groups or differences between offices. And so, as you can see, there is no significant difference between offices. And so move on to the plot to see the interaction and the results of offices and tests interaction. So as you can see, the trend for offices A and B are almost the same. But for offices C and D, after an increase in test 2, office D dropped dramatically at third test. And while, as you can see, at the end of test 3, offices A, B, and C increased, and they're almost the same. Office D, as I said, dropped. So move on and go back to the table pairwise comparisons. You can see here that the p-value for comparing test 1 and test 3 is 0.026, which is less than 0.05, which says that there is significant difference between levels of concentrations of employees measured by test 1 and test 3. So that's it. That was the final result. I hope you enjoyed this video and it was helpful, and I see you in the next video.